Hi everyone. Today we're going to study physical interpretation of mean value theorem. If the position of a moving particle is given by this function s equals f of t at the closed interval of t from a to b, then at some point of time t sub 1, take note that this t sub 1 is inside the closed interval from A to B. The average velocity is equal to the instantaneous velocity, that is f of B minus f of A all over B minus A is equal to f prime of t sub 1. Take note that the left side here is the formula of average velocity, while the right side is the formula for instantaneous velocity when t is equal to t sub 1. Example 1. If s is equal to negative t cubed plus 3t squared minus 3t in the closed interval for t from 0 to 3, gives the position of a moving particle, find at what time the average velocity is equal to instantaneous velocity, s in meters and t in seconds. For our solution, let us write our formula for the mean value theorem. Now, let us evaluate separately the left side and the right side. Starting from the left side, the values for A and B are required. That our A and B are the endpoints of the closed interval. The 3 here is the B and 0 is the A. So for the left side, we will write now f of 3 minus f of 0 all over 3 minus 0. In our numerator, we will evaluate our function here with respect to 3 and 0 respectively. So the f of 3 now becomes negative 3 cubed plus 3 times 3 squared minus 3 times 3 minus the f of 0. So we write here negative of 0 cubed plus 3 times 0 squared minus 3 times 0 all over the 3 minus 0 is simply 3. Simplifying further, this negative 3 cubed now becomes negative 27 plus 3 times 3 squared is 27 minus 3 times 3 is 9. Then minus this whole group here is equal to 0. So we write here 0 all over 3. We can see here that our numerator is now equal to negative 9 all over the denominator 3. And the quotient will give us negative 3. This is the value for our left side. Next, the right side, f prime of t sub 1. We're going to take the derivative of our function and evaluate it at t sub 1. The derivative of this negative t cubed is negative 3t squared. But we will write here negative 3t sub 1 squared. The derivative of 3t squared is 6t. But we will write here 6t sub 1 minus the derivative of 3t is 3. So this is our value for the right side. Let us now substitute the values of the left side and the right side respectively in this formula. So we have this negative 3 is equal to negative 3t sub 1 square plus 6t sub 1 minus 3. Let us now solve for t sub 1. We can see here that the negative 3 is common in each side of the equation. So we can cancel those negative 3's. So we have now 0 is equal to negative 3t sub 1 square plus 6t sub 1. In here, let us factor out a common factor. And that common factor is the negative 3t sub 1. We have now this negative 3t sub 1 times the quantity t sub 1 minus 2. We're going to equate each factor into 0. So we have this negative 3t sub 1 equals 0, and this t sub 1 minus 2 equals 0. For our first equation here, let us solve for t sub 1. Let us divide this equation by negative 3. So t sub 1 is equal to 0 over negative 3. Simply, this is equal to 0. In our next equation, t sub 1 minus 2 equals 0. Let us transpose this negative 2 to the right side, so the sign will be changed. So t sub 1 is equal to 2. We can see here that we have two values of t sub 1. Or we can say that we can change this t sub 1 into t sub 2. So the 0 and the 2 here means 0 second and 2 seconds. Take note that the answers here are inside the closed interval from 0 to 3. So these are our answers here. Example 2. Find the time at which the average velocity is equal to instantaneous velocity for s equals 6t minus t squared in the closed interval for t from 0 to 6. For our solution, let us write the formula for the mean value theorem. Then let us evaluate separately, starting from the left side. So we write f of 6 minus f of 0 all over 6 minus 0. Let us now evaluate our function here with respect to 6 and 0 respectively. So the f of 6 equals 6 times 6 minus 6 squared. Then we'll copy the minus sign. Then f of 0 is now 6 times 0 minus 0 squared. All over, the 6 minus 0 is simply 6. Simplifying our numerator, 6 times 6 is 36, minus 6 squared is also 36, minus 6 times 0 is 0, minus 0 squared is 0. 36 minus 36 is 0, minus 0. So in the numerator, we can simply write 0 all over the denominator 6. And the quotient here will give 0. This is the value of our left side. Now for the right side, f prime of t sub 1. Let us take the derivative of this function and evaluate it at t sub 1. So our f prime of t sub 1 is equal to the derivative of 6t is simply 6 minus the derivative of t squared is 2t. But we will write here 2t sub 1. We have now the values of the left side and the right side. Let us substitute the values respectively. So the left side is 0, and this is equal to the right side, which is 6 minus 2t sub 1. Let us solve for the t sub 1. Let us transpose the negative 2t sub 1 to the left side the negative sign becomes positive 2 t sub 1 equals 6. Let us divide this equation by the coefficient of t sub 1, which is 2. So t sub 1 is equal to 6 over 2, and the quotient here gives us the value 3. This 3 here is with respect to time. Again, we write the unit seconds. 3 seconds. Take note that our answer here is inside the closed interval of t from 0 to 6. This is our final answer. I hope you learned something from this video. See you again next time.